question asks us to assess the overall dipole moment for a given molecule. To do that, we need to find the individual dipole moments for each individual polar bond, and then sum those dipoles in three-dimensional space to see the overall net effect, whether they cancel out or reinforce each other. For this molecule, we have the bonds between the carbons and the oxygen. Oxygen is more electronegative than carbon, so there will be a dipole moment between the carbon and the oxygen, polarized toward the oxygen. The same is true for the other carbon-oxygen bond. Oxygen is more electronegative than carbon, so there will be another dipole arrow pointed towards the other oxygen. What's important about this molecule, carbon dioxide, is that it is completely linear. With two bonding domains and no lone pairs, this molecule takes on a linear geometry. That means that these two individual dipoles are 180 degrees opposed from each other. They're pointed directly opposite each other in three-dimensional space. That means that the dipole from the one carbon-oxygen bond and the dipole from the other carbon-oxygen bond completely cancel each other out, meaning that there is no net dipole in this molecule. That means that this molecule, carbon dioxide, is completely non-polar.